Hello, 7th graders, and welcome to Math Weekly number 8, where our focus skill will be on proportional relationships. So let's begin by defining proportional relationship. A proportional relationship is a link between two amounts that increases at a constant rate of change, which is also called a unit rate. An example would be if Ben has a job working at a local farm and he earns $10 per hour. This is a proportional relationship between the number of hours that he works and his total pay. You see, his total pay will go up $10 every hour that he works. So it increases at a constant rate of change. Every time he works an hour, it constantly goes up by $10. This is an example of a proportional relationship. So let's talk about how we can decide if a relationship is proportional, and we're going to look at 3 different situations. So the first is if we have a written situation. So if we have a written situation, if a written situation is proportional, the following statements are true. 1. The relationship will have a unit rate as part of the problem. Look for keywords like per or each in a statement. So for example, Ben earned $10 per hour, or each hour that Ben works, he earns $10. There also can never be a flat rate charge, a starting value, or any other added or subtracted quantity. So for example, if it said Ben earns $10 per hour and he already earned 30 babysitting, that's an example of a non-proportional relationship because he started with a certain amount. So let's look at some examples. Let's determine if this written situation is proportional or not proportional. Evans Electrical Services charges a $50 service fee plus $40 per hour of services. Does Evans' total service charges represent a proportional relationship? Well, if we look at this problem, we see a unit rate. It is going to constantly go up $40 each hour. However, this is actually a non-proportional relationship because it starts with a $50 service fee. So the total charge is $40 for each hour, so 40 times each, plus $50 more. So because it has this addition, it is not proportional because it has a starting value. Let's look at another situation. Aaron is taking a math test at school. Aaron knows that each question is worth 5%. Is the relationship between the number of questions Aaron gets right and his total percent correct a proportional relationship? Well, we can see that he's getting 5% for each question. So that's the unit rate. It is constantly going to go up by 5 every time he gets a question right. There's nothing that indicates that Aaron gets points from the beginning. He only gets points when he gets the questions right. So this is a proportional relationship because it has a unit rate and it doesn't have any starting value. Let's look now if the relationship is shown as a graph. If a graph is proportional, the following are true. The graph will form a straight line. This straight line indicates that there is a constant unit rate. And second, the graph will go through the origin, which is the ordered pair 0, 0. This means that there is no starting value, flat rate charge, or other added amount. So let's look at some examples. Is this graph proportional or not proportional? Well, think about our 2 rules for a graph. Does it make a straight line? Yes, that means it has a constant unit rate. And does it go through the point 0, 0, which is the origin? And yes, it does. So this is a proportional relationship because it meets both qualities. What about this graph? It has the straight line that we need it to have to be proportional, which means it has a unit rate. However, it does not start here at 0, 0. It starts at a value of 1. That means that this is not proportional because it doesn't meet both the qualities. It has a unit rate, but it does not start at 0, 0. Last, let's look and see how we determine if an equation is proportional. If an equation is proportional, the following are true. 1. The equation will look like y equals a number times x. In other words, the output is equal to a number times the input. This number that's multiplying the x is the constant rate of change, or the unit rate that we're saying it needs to have. And second, the equation will never have addition or subtraction. If you see addition or subtraction, that would indicate that there is a starting value, and proportional relationships never have a starting value. So let's look at an example. Remember, our equation needs to look like y equals a number times x. Do we have y equals a number times x? Yes, so this number is our constant change. This relationship is going to constantly go up by 3. However, it doesn't meet the second requirement. It has addition, which means that it starts out with 5. So this example is not proportional because there is addition as part of the equation. Now, what if we took the plus 5 off? What if it just said y equals 3x? Well, does that fit the form y equals a number times x? Yeah, it's 3 times x. So it has a unit rate, and it can't have any addition or subtraction. Does this have any addition or subtraction? No, so that makes it a proportional relationship. Now, one more thing that we're going to look at in this lesson is called the constant of proportionality. So let's define that. The constant of proportionality is the constant rate of change, or the unit rate, that the relationship is constantly increasing by. In other words, constant of proportionality is a synonym for constant rate of change, which is a synonym for the unit rate. All of these words mean the same thing. So let's look at an example. Ben has a job working at a local farm. He earns $10 per hour. So what's the constant of proportionality? What is it constantly going up as? Well, the constant of proportionality is $10. This relationship constantly goes up by 10 each one of the hours that he works. So let's look at a few different ways that we can find the constant of proportionality. If it is a written situation, just like the one we just looked at with Ben, ask yourself what the situation is constantly increasing by. So here's an example. Aaron is taking a math test at school. Aaron knows that each question is worth 5%. Is the relationship between the number of questions Aaron gets right and his total percent correct a proportional relationship? Yes, this is a proportional relationship. Remember how we said that it constantly goes up by 5%? Well, this going up by 5% is the constant of proportionality. 5% is the constant of proportionality. That is exactly what it is constantly going up by. Okay, let's look at a graph. So if we're given a graph and we want to know the constant of proportionality, write a ratio of y to x using an ordered pair and then reduce to find out how it changes per 1. So let's look at an example. Here is the graph that we said was a proportional relationship because it has a straight line, which means it has a unit rate. That unit rate is what we're looking for, and it starts at 0, 0. So to use a graph, find any ordered pair. I like to use the lowest numbers because we have to reduce them less. So see this point right here? This is the point 12, 4. Write a ratio of y to x. Well, when y is 4, x is 12. Reduce that, which reduces by 4, so the constant of proportionality is 1/3. If you were asked to write an equation, it would say y equals 1/3 x. The constant of proportionality gets multiplied by x. Now, you can double check this. Is 1/3 of 24 8? If you divide 24 by 3, do you get 8? Yep. Is 1/3 of 36 12? If you divide 36 by 12, or divide 36 by 3, do you get 12? Yes. So this constant of proportionality is 1/3. Okay, let's look at one more way. If we have an equation and you want to know the constant of proportionality, find the number that is constantly increasing the x. In the equation y equals the number x, this number that is multiplying x is the constant of proportionality. So, for example, if we have y equals 3x, we have the 3 as our unit rate. This is our constant of proportionality. Our constant of proportionality is 3. This relationship constantly increases by 3. So let's summarize what we've learned. Proportional relationships increase at a constant rate of change, which is a unit rate called the constant of proportionality. No matter how the relationship is represented, there will always be a unit rate and no addition or subtraction of values.